Alright, hello. Sorry, music. Let's see. Oh, and then this. Okay. Alright, where were we? Let's see. Brand new group. Okay, we're counting lines in our beautiful new visual representation. Alright, and I think it was the white objects we're looking at. So 4 lines, is that what you want from me? Let's see. Excellent. Object color greater than -1 and object color less than 65. Meteor color equals 0. What am I equals meteor color? Okay. I don't get it. They told us what color they were displaying. Sorry for the intrusion. Rare appearance from Doppler. Doppler? Doppler, come on in. It's rare to have you in the translation room, but we're happy to have you. Is everything alright with the meteor? Absolutely everything is alright. Also, hi Batista. Hi. The glowing orbs circling the meteor's metal muscle have stopped changing colors. Orbs circling the meteor's metal muscle. Took a while to process that sentence. They've stopped changing colors. They've become dark red, like at the beginning of their spectrum. Is that 0 maybe? Calibrating. Explain. You're calibrating our visual system to display their range of colored lights. Red is color 0, yeah. Soon we will see white, color 64. That is the range of color values they will submit, 0 to 64. In the visual window, I will update to display their color spectrum. I already have a colleague from my team working on passing the meteor orbs' color data into the computer system in real time. And you take those color wavelengths and calibrate your end alongside the meteor. Okay, will do. Perfect. Once again, sorry for the intrusion. Continue to translate as you 4 always do. And keep them focused, Dr. Mew. Okay. I'm back again. Is it white now? Geez, Dob, catch your breath, sit down, take my seat. I'm alright, and you were spot on, Batista. The orbs are white? Yep, blindingly bright white, the end of their color spectrum. Color 64. And I spoke with my colleague, he says the color data should be patching right in. Yes, I see it. I will have the color viewer up soon. Perfect. Geez, he's in a hurry. His team has investigated a motionless meteor for nearly 4 months, and now its colored orbs have finally come to life. I think he's happy to see some change in the room and eager to get back. Okay. Okay, color display up. Visuals window, I assume. Button for it in the top right of the window. Meter color azure. Color point 50%. 32. Okay. Thank you. I think we'll need it for this one. Nice. Okay, so what color is this? That must be 8 then, right? So this is like 12? No? Do I need to convert this into base 8 to... How do I do that? Base 8 round? Would it just be... It would just be 15.6% of 64, right? I don't know how to work. You take percent symbols? No. Base 10 to base 8. Does that help? Batista, I need basic math help. Okay, if I wanted to get... If I wanted to get... 10% I know must be 6.4. So that would be times 1, right? So do I just do times 156? No, that's not right. It's, or is it? Nine nine eight four. 10. Oh, okay. Batista, you seem to really like computers. Nothing gets past you. I'd love computers too if I were as good with them as you are. Is that how you see it? Skill precedes passion? If I was a musical prodigy, then I'd play music all day. Interesting. Interesting? You have it reversed. How's that? If you played music all day, you would become a musical prodigy. I'd be a musical prodigy if I was born with the talent of a prodigy. Would you not become a prodigy? Okay, so now we want 781. So 50. Six, 4, 1. Okay, visuals now use the color range. Yeah, I can't wait to see it. Okay, 875. What was that message? Oh my god, will this message stop? Let's see what this looks like. Over 1,600 signals. I need to make a faster compiler. Over 1,600 signals for one super object? What exactly are they drawing for us? Themselves? Hmm. Aliens? Nice. Doppler, it's quite amazing what we've seen. It's something you should see for yourself sometime. What is it, Collins? It all depends on our interpretation and confidence in signal -45. Dr. Mew's interpretation of aliens. Because we believe the meteor has sent us a portrait of aliens. Whoa. Incredible, right? The render is quite low in detail, bound by the amount of signals it takes to produce a superobject transmission. The transmission was over 1,600 signals. May I see it? The visual you rendered? Alan took a picture to show you. Photo from aliens. Here you go, boss. Huh. So that is aliens. If only we were confident in our understanding of signal -45. That brings us to my hypothesis. If we were to create a message with visual capabilities, what would be our first message to share? A circle to calibrate the resolution. I'd send Planet Earth our sending address. Those are both sensible ideas. But Collins, I sense you have something else on your mind. What is it? What would be your first picture to send? A picture of a human. Color calibration and glimpse of an alien. Hell yeah. Alan's journal. Status hopeful. I stand by my answer. Sending a picture of Earth to aliens would tell them who sent it, from where, and in a sense it would be a portrait of all of us, our home in the cosmos. Working on a color display is amazing. Dear Diary, I believe the aliens have sent their first self-portrait. Our relationship with the meteor, it's changing. And so our relationship with the aliens to our future understanding. Would. Your colleagues have some ideas for what these signals mean. Okay, nice. Act 4 begins. Okay, let's see what you think of these terms. I guess a nice one for super object might be sculpture or something. I'm still thinking about that last transmission. What in the world was that? It was so lengthy. Alright, new computer update. Now the compiler prints all of the output signals at once. Oh. Oh, what? No more giant scroll? I love that part. Really? Yeah, it was great. Okay. I will push a new update. It will do the full print for transmissions below 256 signals. Otherwise it condenses. You do that for me? You're the best, Batista. Okay, no hugs. Too close. Alright, I'll respect it. Let's see. We did all these as well, right? Yeah. I mean, there's not much else they could suggest for these, right? Object. What do you guys put for this? Orb, visual object, drawn sphere. Okay. Color. Oh, you don't have anything for color. Image, visual frame, 3D drawing. Okay. Let's go with, I feel like, block. And sculpture. I think that's nice. Okay, what have we got now then? New concept. 1, 2, 6, 26, 92, 118, 210. So it's saying this term 1, and this term 2, ... then this term 6, ... and 26, 92. Okay. Not sure what that could mean yet. Then we have another new term. So this term equals something count 1. This new term 1 equals something 1 count 1. This new term 2 equals something 2 count 1. This term equals... Why doesn't it have a 1 in this one? What did the previous one look like? I assume it's going to be 1 again, but... I'm not sure what it's trying to say yet. Hang on. Could be something to do with chemistry, right? What is it? Protons and... Isn't there something that there's always the same number of something in atoms? The proton count is usually the same as the electron count. Because this is saying the something is always equal to the something. So when there's one of these, there's one of these. When there's two of these, there's two of these. When there's three of these, there's three of these. So what does... Protons in its nucleus. What is that periodic table? What were the numbers we just saw? One, 2, 6, 26, 92, 118. Does this have anything, any significance? 1, 2, 6, 26, 92. 2. Carbon. (26) Iron. Seems pretty significant, doesn't it? What's the relative abundance? 1, 2, 6, 26. One, 2, 6, 26, 26, 92, 118, 210. Uranium. I am gonna very tentatively call this proton? An electron? I don't know, maybe I'm way off the mark, but... And what is it actually counting then? There's still one atom, maybe? I don't know. Let's see if we get new information that ruins this idea. You guys check it, it's sculpture again. Dr. Mew, switch to the visual tab. Can I get a picture of a... Is that what I'm looking at? Let's see, what did they say originally? So it wants something else. Do I have a word that means, like... bond or something? Maybe I'm off the mark with the proton thing. Not really sure what to make of this. What did the other one say again? I guess it wouldn't make sense if this was protons, would it? Although this works out nicely. I guess maybe I'm reading this wrong though, right? It's saying that this object is equal to the number of this object. Yeah, that's... Okay, first thing I should do is I should fix the formatting for that, because that is a bit confusing. Let's interpret it like that instead. Although again, how is count formatted? Because it's been a while since I saw count. What did you guys hypothesize for this? Quantity, number, amount. Let's go to basics. Maybe it's more like elements or atoms or something. How... It's like 1, yeah, element 1. Element 2, maybe it's element. So A... So something equals what? Element count 1. Something 1 equals to something count 1. Oh, is it just because I missed the number of it before? Hang on. Ah, okay, okay. Does it just want me to do count now then? No. Let's see what the guys want to say. I get it, we have to respond with the number that follows UncB. We're naming it or labeling it. But what do we go on? The visual window provides our one true clue. That's what I thought too. But I just see a cluster of 3 blocks circled by 3 more mini blocks. Makes me think 3 is what they're looking for. Either that or 6, I suppose. Isn't it just always 1? So do you want 3? You do want 3. So this time they want 6 then, I guess. So is this carbon, maybe? So 1, 3, 11, 19, 37. 1, 3, 11, 19, 37. Oh yeah. Okay, Anke has to be element, right? Element is in an atomic element? Now that'd be something. If we can discuss elements, we open a whole new world of communication. Okay, 4, 12, and then something, and then 38. So 20. Hold on. Okay, and then variable 1. Set 17. So 36, 54. The 3 before 36 and 54. So 2, 10, 18. Nice. So what is that other term, I wonder? Strange. Or atom, maybe? Let's see. Atom. What do you need? No, I said atom. The dictionary, look. Oh. Ooh, we can talk about atoms with the aliens, then maybe we can talk about the real world. Okay, cool, cool. Let's see. If element number count is greater than element 1 count, assume that set 0 contains them both. Huh? So what do you guys want to say? So one for the previous one. What is this? It's a hefty message, but it's not making any sense. We have 18 sets labeled 0 to 17. Why? They're just lumping a bunch of elements together. Use the visual calculator brain picking up any pattern? This is not math, it is something else. It's organized like a table. If it isn't math, what are the starting points would the aliens work from? What else do we have in common? Why are there 18 sets? Why 18 groups? I suspect that holds the key. I'm gonna peruse the reference tab. Yeah. I'm actually ahead of them on this one. We're dealing with element, but why is count here? Good question. They are sorting the elements by frequency. By frequency, as in abundance in the universe? Okay. Oh, I see. Yeah. So if there's more 0 than 1, then put 0 before 1. If there's more 3 than 2, then put 3 before 2. Okay. So I need... Let's see. 1, 2, 8, 6... Atom fits in Meteor 0. I should think so. Oh my goodness, Batista, that's how you defined a planet? The reference tab might... hang on. The reference tab, I was looking through it and my goodness, you ruined the info I gave you. Planet, a large sphere smaller than a star that orbits a star. What is incorrect? Nothing's incorrect per se, but it's missing both nuance and cold hard facts. You've ruined it. The reference tab is not all explanatory. Having the essence is likely enough for us to progress. If the definitions upset you experts, then oh well. An expert, you say? I like the sound of that. That is all it takes to get him off my case. I'm an expert, Dr. Alan Akers, expert of astronomy and astrophysics, the charger of the skies, watcher of stars, moister of... He's still going. Okay. Atom fits in Meteor 0. Okay. 8 to the power of 27 atoms fits in 1 Meteor 0. Okay. Well, I mean, one atom definitely fits in one meteor one, but okay. Covers or fits in or area equals 2 atom 1 covers, I assume? I mean, I don't know much about chemistry, but I assume 2 atoms is bigger than 1. Dr. Batista, would it be alright if I sent you some information about linguistics? For the reference window? Yes. Sure, send it over. Covers or fits in or area equals atom 4 something atom 8. Fits in. Atom 3 something atom 3. Area equals 1 something area equals 1 atom 10 area. Atom 10? Atom 8 covers atom 1. Atom 8 fits in 64 atom 1. Okay. 16 atom 2 covers atom 5. Okay, covers or fits in. Okay, so how do you want this formatted? Okay, atom 1 fits into atom 1. Oh, it's telling me the answer, okay. Atom 8 covers... Wait, why does it tell me the answer for that one? That's... Okay, atom 8 covers 2 atom 1? Or does it? Yeah, it must do... I'm not sure, I mean, I assume it's larger. I think it's covers. One whatever atom is going to be bigger than 2 hydrogen atoms or whatever that is, right? And atom 8 plus 2 atom 1s I think still fits in 2 atom 8s. And atom 8 plus 2 atom 1s fits in. Let's see if I'm right. Okay, good. Nice. A good day's work. How's the dream team going? We're a dream team? I guess that makes me the wilt of the group? Huh? What did you just say? Are you out of your mind? You'd rather be wilt when Bill Russell is in the league? You kidding me? You don't want a 100-point game under your belt? What are they talking about now? Basketball, I think. Wilt Chamberlain is the greatest player to ever touch a basketball. I'll take 11 championships with Russell. I'd rather have him on my team. If we're talking about individuals, then it's all about the individual impact. Team results are all that matter. Back on topic, please. Or dismiss us. But, Dr. Akers, you've said your piece. The meteor, what are your findings, translation team? It all has to do with element and atom, as named by Dr. Mew. Dr. Mew, how confident are you feeling on the definitions? Yeah, pretty confident. Are you finding success? One transmission related the terms to atomic abundances, and they matched our data from the reference tab. It is a fragile tower of definitions we are stacking, which is why testing our understanding to real-world data is gratifying. When we find connections like these, we can be sure our translation is progressing. It's good to hear. Now go home and get some rest. For another week full of discoveries lies just ahead. We will see you then, Doppler. Good night. Alan's journal. Status frustrated. I'm worrying about the wrong things again. We've got an alien meteor in front of us, yet I'm still stuck in my old ways. I know how I should feel, but I simply don't feel it. Batista's log. I again entered a good deal of information into the reference tab, so much so that I made none of it my own. Dear Diary, I get the sense that my colleague and friend Alan is losing motivation, but I don't know what to say to help. I don't think I've ever been good at that. Doppler's report, nothing. News thoughts. What the hell is a basketball? Okay, how are you guys feeling about these? Element? What, you guys haven't... Come on, guys. Atom instance. Okay. Okay, complete. Pardon, what exactly is complete? Oh, the linguistics reference. Okay. Swadesh lists? The fuck is that? A list of words likely to find in every human language. I, one, not person, big, what, head, eat. Cool. Grammatical versus ordinary words. For example, do and did carry little meaning, but are often auxiliary verbs or helping verbs, such as in the sentence below. Dr. Batista did not inform his colleagues of a valuable update. Most words are ordinary words, meaning they carry an inherent meaning. Dr. Batista inform colleagues valuable and update are words that carry specific meanings rather than assist in structuring a sentence. Across human languages, ordinary words can become grammatical words. This is grammaticalization. In English, had, for example, has been grammaticalized. Note how going is used differently in the following two sentences. Dr. Doppler had to run back to the materials team. Grammatical. Dr. Doppler had many papers in his hand. Ordinary. Interesting. You added it. Thank you, Batista. It is unlikely to be relevant now given the latest transmissions. Perhaps later it will assist in our translation, right, Dr. Mew? Okay. New signal. This thing contains atom. Okay. Maybe it's gonna be like molecule or something? Atom. Yeah, looks like it. Let's see. Molecule? Like one instance of a chemical compound? I think I see what Dr. Mew's seeing. The aliens are describing substances by their atomic makeup. Okay, molecule 0, atom 1, atom 1. Molecule 1, atom 2. Okay. One, molecule 6, atom 1 count. 2. Does count always push to a new line or something? Why does it always look so odd? Yeah. Okay. So molecule 2 is 2 atom 1 atom 8. Do you need the brackets? Yes. 2 atom 1 atom 8. Okay, molecule 0 is 2 atom 1, 2 atom 8. Why was there no space after that? Interesting. What's happening there? Where's comma? I see. So, because numerals don't get the leading space, do they? Why was it like this in the first place, I wonder? Anyway, 2 atom 1s, 2 atom 8s, and an atom 20. 2 atom 1s, 4 atom 8s, and an atom 16. Okay. I actually don't know how to work out which... Maybe you just add them up. 2 plus 16 plus 20. So 38 or Okay, so this one would be bigger. So fits in. Let's see. Okay. Okay. So add these up, you get a molecule 3. Okay. 2 atom 1s, an atom 2, atom 6 and atom 8. 2 atom 6s. 2 atom 7s. What are you going to ask me? If you add 2 molecule 0s... Okay, so 4 atom 1s. And a molecule 5. Okay. You get 2 what? What else has 7s? Would that make... Interesting. Does that make 2 molecule 6s? Wait, it's 2 molecule 0s, right? So we have 4 atom 1s. We have 7 atom 1s and 1 atom 7. How does that make 2 of anything? Maybe it is 2 molecule 6s. Let's see. Oh, it is, okay. Gonna have to learn how chemistry works. Let's see. Molecule 0 is atom 11. Molecule 1 is 2 atom 17s. Molecule 0 plus molecule 1 is 2 molecule 2s. Atom 11. Maybe it just wants me to type out all of the contents, right? So 2 atom 11, 2 atom 17. No. Oh, equals 2 molecule 2. Oh, okay. So okay. Okay, it's always awkward reading this sometimes because of the way it ends up getting broken up, but I don't know a better way to do it. It's saying that if we add some number of this molecule to 3 of this molecule, we get 2 of this molecule. Okay. Why do we only end up with 3 atom 8s then? No idea. But if we end up with 2 atom 26s, then there must be 2 of these, right? Let's just go with that. No. Maybe I need to know actual chemistry at this point. Let's see what the guys say. We need to balance this equation. Oh, is it going to be math? We need the same number of atom on each side of the equals. So let's take inventory. How many atoms are currently on each side of the equals? I guess there's 3... Well, I mean, it depends on how many molecules they say there are, right? On left is 3 molecule with 2 atom 8. Totals to 6 atom 8. Oh, okay. Yeah, but then I don't understand how... And on right is, let me see, we have 2 copies of a molecule with 3 atom 8 and 2 atom 26. Which means the right side has 6 atom 8 and 4 atom 26. Math good. Okay, so I just have to look at... How is that not 2 then? Am I stupid? Oh, because there's 2 molecules, so there's 4 of them. Okay, I see. So I need 4 of these. Yeah, I'm gonna be really bad at this stuff. It's back to numbers and math. Okay, 2 molecules with 2 atom 1 each. Okay, so 4 atom 1s. 2 atom 8s. Equals... two atom 1, atom 8. Okay. Chemical compounds. Okay, new concept. Molecule variable 0. Molecule variable 1 something molecule. Variable 2. Okay, where's the reference tab? Assume this is some sort of, well, reaction or something. Is that what this is saying? So this and this react to form this. So 2 atom 1 react with 2 atom 8s. Isn't that lopsided then, though? What are 1 and 8? 1's hydrogen, and 8 is oxygen. Oh, so that's literally... Okay. So what am I looking at? So this would be 2 hydrogen. Then shouldn't this be 1 oxygen? I don't know. And then 1 molecule 1 and 2 molecules 0. That's correct though, isn't it? Okay, and then 2 molecule 3 is this. Would react to form, let's see. Two of these gives us 4 atom 1s. They can all become this. And 4 atom 8s. So 2 would become that, and then 1 becomes this. So molecule 1. Okay. So now we've got what? One atom 11. We've got sodium. A chlorine. Okay. And then something that uses both. So as long as you've got 2 0 and 1 1, you can make this twice. Though I'm not sure what it's asking me to say here. What do I want to call this term? It looks like it's reaction or something, right? Or react. React. Good catch, Dr. Mew. Okay. What do you guys want to say? React seems very similar to equals. Oh yeah? Remember earlier in the logic section? We learn that covers has the same core meaning as greater than. It's reserved only for the domain of geometry. And you're thinking react is the same? I think react is the equals of molecule equations. Why there is a separate word defined for this, I haven't a clue. What do they want me to put here though? How was it formatted previously? Molecule 0. Molecule 1. React to molecule 2. Okay. React equals molecule sum. Or react equals molecule what? Equals. No. Multiply? Minus? I don't know what you're asking me, computer. Okay, so it can be breaking them apart as well. Sorry if you can hear me drinking my coffee. Okay, new term. You have a set containing a variable, a molecule, a reaction. And that's equal to... Why isn't the brackets closed? Is that all you want me to put at the moment? No. Oh, it closes twice, I see. So atom 1, something forms a molecule with 2 atom bonds. Is that not just react then? Yeah. Is this term fusion? Ah, 4 years at undergrad, 5 years at grad school, and nearly a decade with the space agency. Dr. Akers? And I can hardly follow along. Okay, so this thing's 0. which is 2 molecule 0, which is 2 atom 1. Oh, I see. This is just, okay, UNC 0, which is 2 molecule 0s, which are just 2 atom 1s. And 1 molecule 1, which are 2 atom 8s, react to form 2 molecule 2s, which are an atom 8 and 2 atom 1s. Okay. Maybe that's process? Oh, I see. So this is saying that the reaction is symmetrical. Is chemistry symmetrical like that? I don't know. No? Interesting. The aliens want us working with Atom 2, huh? Takes me back to grad school. Berkeley, was it? What was your research? Mapping space with radio astronomy. Assume that element 2 does not react, I think is what that's saying. So if element 2 is not reactive, then atom 2 is not reactive, right? Okay. In grad school, I worked every night at the Lushna Observatory, recording waves, charting the skies, and in the daytime, I'd dig through the data, piecing together trends and searching for anomalies. Day and night on research, not much time for a social life? I'm afraid I can relate. I as well. Batista, I'd reckon your lack of friends began long before grad school. Which one of us is married? You're married, Batista? 15 years strong. Well, good for you, Batista. Guess there's hope for people like me. No, there is not. Okay, assume element 2 does not react. That means there's only one of those. Okay. Dr. Akers, what is radio astronomy? You mention it in your graduate research. Ah yes, the universe is full of electromagnetic radiation, light waves. The only problem is the frequency of most of those waves is beyond the visible light spectrum, so our eyes can't see most of the information out there. So you'd look for the invisible part? Yep, like the hydrogen line. Hydrogen atoms change state and release relatively harmless radiation. And when they release this radiation, it's at the same exact frequency every single time. The aliens were clever for picking that frequency as the basis for all their transmissions. With hydrogen's overwhelming abundance across the universe, it's plain brilliant. And the consistent frequency makes it universal. It's the perfect way to say hello. So I don't really understand what that part means exactly. If element variable 0... Okay, if we assume that element variable 0 does not react, set 17 contains element variable 0. Okay. Set 17 contains element 2, variable 1, 2, 3, 4. We assume element variable 0 is not reactive. And set 17 contains element variable 0. What? What are you asking me? There are non-reactive elements, right? Isn't that these ones? In 16, 17. Maybe it's these ones. Although maybe this is literally element 2 though. Maybe this is saying element variable 0 just means non-reactive elements, so set 17 contains non-reactive elements. It contains helium and then 4 variables. What are the variables? So it wants element 10, 18, 36, 54. Let's give that a try. Okay. Now I'm reminiscing about my days at my grad school, and at the observatory. Oh yeah? We'd only listen in for one frequency at a time, which is what our satellite dish was made for, amplifying large wavelengths. But I found ways to analyze the interference to derive additional frequencies, so you could get more data out of it. Right, then we'd adjust the scope's angle ever so slightly for the next night and repeat this week. Snapshot by snapshot by snapshot, I listened to the fundamental emissions of hydrogen, the hiss of the universe. I listened for light we cannot see, and I tried to make some sense of it. The hydrogen emissions, trying to make sense of it. Sounds all too familiar now, huh? I bet you feel at home here, Dr. Akers. Ah, you'd think. Okay. Alright, atom equals element count 1. Atom forms molecule. Alright, there's a term we haven't defined yet. So how else has this been used? Do we have a term for whatever that is? I don't know. Is it bonding, maybe? Well, let's see. What do we have here? So I'm not sure what this is supposed to be exactly. Did we use this term when we were doing water? What is this, right? Maybe it is bond. Although the guys didn't say anything, so maybe not. Okay, so what are you asking me here then? It should be React, right? Yeah. My research was mapping out the Milky Way. We knew its rough shape and size well before the early 60s, but my principal investigator wanted to map it in detail. We surveyed the galaxy's spiral arms, their densities, the rate of rotation, how they would all undulate independently, and the part that gets me going, their elemental composition. How large was this project? How long did you work on this? 4 years, every day. That was my life. Adjust the telescope, record data, and analyze. It was a slow, tedious, and highly granular process. Complex tasks, one step at a time. With a fine-tooth comb and an eager eye. It's the same story here. Only the stars have come to us. Atom forms meteor, and atom forms aliens, and atom forms humanity. Cool. What's new? We've learned about molecules, which are atoms that are bound together. They have also honed in on one element in particular, helium. Helium, why? Akers, chime in here. You know your way around the periodic table better than the rest of us. Oh, well, helium's the second element on the periodic table, with only 2 protons. Helium atoms are tiny and very abundant, second only to hydrogen across the universe. And they're noble. Noble? My chemistry is not the best. I could use a refresher. Noble means nothing will react with it. Helium atoms never react or form compounds. Just like the rest of the other elements in Group 18. Helium, neon, argon, I think krypton's next. It's a pretty unique feature among the elements. Wait, that list of elements, that list is familiar. Let me check my notes. Oh my goodness, Akers, you're a genius. 3 transmissions ago, those were the elements listed together. Yeah, we solved all this, guys. We're trying to keep up. Good find, you two. But what does this mean? It confirms that element and atom represent element and atom. I wish the aliens could see Dr. Mew's dictionary and draw a big fat green check mark across the words we have right. But they don't know our language. Of course not. But they're finding ways to validate our understanding of their words. Validation is rare, so let's savor this. Seriously, Akers, Collins, Dr. Mew, great work. Hi. Batista, I still feel bad about the color display mishap. Sorry about the miscommunication. And all of you, take care, get some rest. See you in the morning, 6 o'clock sharp. Alan's journal, status timid. I managed to help confirm some of our dictionary words in the meeting this week, which feels good. But it was really the brilliance and attention to detail of Carrie that pieced it all together. Regardless, I'm glad I helped some. Dear Diary, Doppler put it very well. As is par for the course of uncharted discovery, validation is rare, so we must savor our affirmed triumphs wherever possible. I'm way ahead of these guys. Nice, let's see what the guys think then. 3 new signals. Molecule. Compound, molecule, chemical. React. Chemical reaction. Batista, what is this? Reacts to form. Chemical reaction again. Transformation. I don't know, it seemed to suggest it was only one way. Let's see where things go. 3 new signals, goddamn. Okay, 60, 61, 62. This is our new chapter. Oh, okay, so it's going to be protons, electrons, and neutrons. But which is which? Okay, 160 and 162 forms atom. 160 and 161 and 162 forms atom 1. 160 and 261 and 162 forms atom 1. Okay, you're gonna have to help me out with that one. Let's see. Okay, so it does have isotopes. So weird. So 61 must be neutron. Neutron's the neutral particle. Like Batista. Exactly. So, a proton and electron with a neutron, a proton and electron with 2 neutrons, okay. And we've got atom 2, which has 4 isotopes. Atom 2, atom 2. You do not have 6 neutrons then. So this is carbon, I guess? Okay. So 62 fits in 60. Does that mean 62 is electron? Because they're the tiny ones, right? See if the guys say anything. Okay. Electrons, the smallest thing we've defined so far. Yet it still takes up a frequency just like every other word. What does that mean? Not sure, thought it sounded poetic. Maybe I should be a poet. Do not quit your day job. This is my day job. Whoa, protons. I hope you're right. Protons, neutrons, and electrons. We've got them all. Now it makes sense why the three were all defined in a single transmission. They were defining subatomic particles. It's all making sense for now. Now let's continue. Okay, assume electron fits in proton. Okay. Proton fits in not electron. No. What are you looking for here? I mean, I suppose it literally... No... I'm not sure if the not is applying to electron or the word I'm doing. When was the last time we saw them use not? Oh god, it's probably been a while. I have no idea. Okay, I'm negating this word, I think. It's weird that it's not covers then. Or fits in rather. Maybe I spelled it wrong. Okay, no, it's definitely not. So what do I know about protons in relation to electrons? Maybe we'll see something about charge. I wonder. No. Not gain? No. Because they're neutral. Oh no, protons are... Neutrons are neutral. Protons are positive, right? Not lose? I'm not sure then. What could you possibly be looking for? Does it want not equal? Because it's so much... Oh, okay. I was good at what I did. At the observatory at grad school? Yep, I'm not one to brag. Turning a new leaf? That was pretty great, actually. It wasn't just grunt work I did. I picked up on patterns. The younger a nebula, the higher its metallicity. Metallicity? It measures the ratio of hydrogen and helium compared to every other element. Metals to non-metals. That's what us astronomers care about when it comes to atoms. We keep it simple. If it ain't hydrogen or helium, it's a metal to us. Drives chemists nuts. So higher metallicity means less hydrogen and helium and more other elements? Right on. And hydrogen and helium are the elements with the lowest mass. Which means a higher metallicity means a higher density. So I postulated that a higher metallicity would accelerate the nebula's accretion into a star. Gravity is dependent on mass and distance. And more mass in a smaller distance would mean gravity does its job all the merrier. Plus the star would have more fuel to start nuclear fusion. And then, whoa, slow down. It's been too long. Way too long since I've been in an observatory. I don't see that changing anytime soon. Okay, proton area equals neutron area. And proton does not equal neutron. Assume proton covers electron. Okay. Remind me. Proton count is usually the same as the electron count. And the number of neutrons gives you isotopes. Okay. Well, neutron also covers electron, right? Okay. Dr. Akers, are you saying that you worked on your thesis for 4 years? That's thorough, to say the least. Nope, that was my PI's project. It was his research, his paper. I was the third author, which ain't bad. But, you know how research goes. And how's that? The little red hen bakes the cake, and then the PI eats it. 8 proton, 8 neutron, 8 electron forms atom A, I guess. Transmission 256, halfway to 1,000. Carrie, I think he's finally off his rocker. Did we tell Doppler? Settle down, let's hear him out. He's doing base 8 again, I imagine, yeah. In base 8, the digits 400 are equal to 256. It is the halfway point to 512, which is digits 1000. Oh, we're doing this again. I hate base 8. Why must you keep bringing us back to those dark times? Embrace the aliens, think like the aliens. Okay. It's the electron. Cool. Yeah, so are you going to be asking me... So this must be atom 2, right? Okay, new term. So what is 2? Is that helium? 8, 8, and 8. What element does this form? Huh? Wait, what are you talking about, Collins? Is that... Wasn't that like 2 questions ago? I've got a good guess. By the base 8 numbers, I'd guess that element 8 is their favorite. It may be one of humanity's favorite elements too. Let's see. 8. Oxygen. Okay, we have atom 1, atom 1, atom 2, atom 2, atom 10. Okay. Something 1, 1 is atom 1. Something 1, 1 neutron count equals 0. These isotopes then? Yeah, isotope 2. 4. Isotope 2, 3. So this should be 13, no? Yeah. Let's see. Isotope works. Good. I will turn off log now. Oh, okay. Let's see, isotope 13. Oh, that's its mass. Okay. There's 14 neutrons. Let's see what the guys have to say first. Alan, I hope this isn't too forward. I've been thinking about what you said about grad school, the research. Being third author on that paper seems to trouble you. Maybe more than it should. And I'm no astronomer, but it sounds like an incredible paper. Something that you helped make possible. Shouldn't that be enough for you? Yeah, you're right. Journals loved it, and it was highly cited. But that's not what people care about. They wanted to meet my PI, the one man behind it all, ask him every question and he'd have an answer. That's the thing, people just look for a face, a figurehead, someone to give all the credit, someone to accept the prestige. It's perhaps a troubling way to think, Alan. I know, I shouldn't even care about all that fluff, that recognition. I know it should be about knowing my own skills, my own impact, but I don't know. Just don't feel it sometimes. Ooh, so this is a helium and a hydrogen, I guess? Or something like that. Oh, maybe they're just isotopes of the same thing. Not sure what the... Okay, hold on. Have I got this wrong? Well, I guess that does have 3 isotopes. What is this saying? 2 isotopes. Let's see, what do you guys want to say? Dr. Mew, I'm seeing 2 different units in this sculpture. I imagine we have to name them properly. Oh, I see, yeah, it wants the 2 things. One consists of 1 proton and 0 neutrons, while the other consists of 1 proton and 1 neutron. Yeah, so it must be helium, right? What does it want me to put there? Aren't they both isotope 0? Okay, I'm not sure I get... Hang on, let's see what the other ones look like. There's no way it wants it formatted like this, is there? Oh, I guess it's isotope 1, not isotope 0 as well, isn't it? Oh, it would also want the brackets, I suppose. What do you want me to put? This must be how it's formatted, right? Does it want, like... like that? Come on. What? Oh wait, wasn't the second number mass or something? Mass doesn't change though, does it? Maybe you want that? Okay, what do you want from me, aliens? What am I supposed to say? Maybe you just want isotope 1-1. What? What am I supposed to put then? bit confused now. I imagine we have to name them properly. I mean, what was that really long way that they did it before? Like this, maybe? Did I already just do it like this? I think I did, right? Okay, if that's always just mass. Why is this second number... Usually this is mass, and then I guess here it isn't. In this case, it's just saying it's the second isotope of element 1. It'll be something easy like element 1 isotope 1. It's not gonna work, is it? Atom 1 isotope 1. The naming for these things is inconsistent. Because here it's mass. Here it's not mass. Or is it? Do neutrons have mass? Oh, maybe isotopes have different mass then? Bleep bloop. What? You said something? No. Huh? Okay then. Or maybe it is mass. So, do you want... Isotope 1... 1... and isotope 1, 2? What? What do you want from me? This is a bit dull, because this is just struggling with how exactly they want me to phrase this. I really don't know. I guess this is actually first. mean, this seems to be the correct way to format these, doesn't it? What? Fuck's sake. Okay, so you... Okay. Alan, if you're sitting in this room with Batista, Dr. Mew, and I, it means you're in good company. You're not here by mistake. People know your worth, the unique value you bring. Yes and no. People see that I'm good enough to get by. Even on the Apollo program, I did what I could do to help. They had enough astronomers telling them the flight path to the moon was clear. So you ran for coffee. Coffee, donuts, and later on some moon rock spectroscopy. A pretty robust background, ain't it? I would leave the first two off any resumes. You say that now, but just wait and see how good I am at my coffee runs. Okay, so we're not sub-bracketing even though there's commas. Okay. Okay, now what am I being asked? The atom is it's equivalent to the number of protons, right? Alan, you are insightful. You must know that. We need you. For coffee. Batista! No, we need you to decode this message. It's probably been 2 months since I've last helped with anything. I hardly help solve the transmissions. I don't program our computer, and I don't do any linguistic analysis. But you start the discussion, Alan, you spark ideas. Even if you're wrong, you get us to think in a new way. I speak a lot, that's for certain. I suppose there's a minimal amount of help there, though I'd hardly call it expertise. Dude, Alan, you're being a total bummer right now. Okay, new thing. Isotope 1 mass 4 something equals 1 neutron. What is this? How could... Isotope 1 and 4 something. Or is it isotope 1 4 something? Is equal to the sum of isotope 1 3 and a neutron. Okay. Isotope 1 3 something is equal to the sum of 1 electron and isotope 2 3. This is strange. Isotope 2 6 something is equal to the sum of 1 electron and isotope 6 3. What? So is this going to be 714? Okay, I'm not sure I understand what's happening yet, but... Well, this is going to be isotope 1 4 again, isn't it? Alan, the hydrogen line. What? Something you accomplished. You start the conversations, but if that's not enough, then look to the hydrogen line. The very first transmission, the basis for every frequency we've received. I'm aware. If it weren't for you recognizing that specific frequency, would we be this far? We could have been stuck for weeks trying to deduce some meaning from those numbers. But you noticed the hydrogen line, you established our starting point. The aliens waved hello and you were there to see it. I know, it's been my pride and joy these past 4 months. But that's it, I'm running on fumes of achievement. We're a team, Alan. All of this is your achievement. The hydrogen line is my achievement. That's all I have to hang my hat on. You must know that there was a reason Doppler wanted you for this mission. You know the universe better than any of us. Well, anyway. This thing is... So it can bond protons and it can bond electrons. So this is nuclear fusion, I guess? Let's see, if I call this fusion, will the guys say anything? Or fuse? No. Reaction? You just a bond? Gain? And? What do you want from me? Oh, maybe it wants me to say like neutron bomb? Oh, okay, that was fair enough. Whoa, what is this? Okay. Variable 3 is equal to... variable 0 divided by 1? Hard enough for me to do regular math and have to, like, remember how to read these statements. And then... what is this? 0.5 to the power of variable 3? Multiplied by variable 2 equals 64? Yeah, equals variable 4. So if everything is 64, what is variable 4? Okay. So variable 3 is 1, right? Let's see. That's the only place we use variable 0, isn't it? Or variable... whatever. Yeah, variable 0. Okay. So variable 3 is 1. Okay. Then we have... I think this is 0.5 to the power of 1, right? Is 0.5, okay. Multiplied by variable 2 is variable 4. So that's 32. Oh, is that it? Okay. Just making sure I can still do math, I guess.
Okay.
I have something to say. Many years ago, my older brother played in the Los Angeles Philharmonic. In the orchestra? It sounds quite prestigious. He even became the third chair percussionist, so he invited the whole family to his debut with the orchestra. The first percussionist was standing with the snare drum, a triangle, and an array of other instruments. My brother was sitting 2 chairs over. He remained sitting for most of the performance. I thought back. At age 8, my brother was playing Beethoven on the piano. From high school, he was first chair percussionist in the school band. Each time he visited from college, he showed me a new instrument he had learned. And now he was third chair in the entire symphony. Yet he was sitting. Nearly 10 minutes had passed and he had hardly played a single note. He hardly played at all that night. I'm sorry to hear that. Another passionate soul lost to the crowd. That is how I thought at first, though after some thinking I realized it was all the part asked to him. That's the point. It's a shame to waste such talent. He sounds like a brilliant performer. The symphony should have had him play more. Maybe. Maybe? Would the songs have been better if he played more notes? Okay. What is all this about? Okay, so given this formula, If variable 3 is 0, then variable 4 is 1. If variable 3 is 1, then variable 4 is a half. If variable 3 is 2, then variable 4 is a quarter. If variable 3 is 3, then variable 4 is an eighth. And then a 16th. If variable 3 is 8 to the power of 8, variable 4 equals variable 5. Is variable 5 greater than 0? I mean, I guess so. It's just getting smaller and smaller, right? Okay, no question here. So, new concept. Okay. X, Y, Z, this. Okay. What is this formula it keeps giving me, I wonder? Do I have this somewhere? A equals T divided by H. Right, so this is the formula for radioactive decay. Okay. What do you want to tell me, guys? What is this? Different isotopes, each undergoing fuse. Hold on, let me check our periodic table in the reference tab. Why? What are you searching for? It's just a hunch for now. Found it. What is it? It's the half-lives. In the reference tab, check out the periodic table. I think it has to do with the half-life data of certain elements. Oh my goodness, good find. So how do we just respond? By comparing the half-lives of the isotopes. It is a ratio they are expecting. Okay. So I wonder if 65 is decay? It's kind of weird it would be there. Oh, unless it's about time, and they're using this to objectively measure time. Based on decay rates or something? Time? Time, Dr. Mew, what do you mean? You mean time as a concept. Time. That which comes before and inevitably comes after. The independent variable of existence. The natural progression of matter in space. Things to be done and things already done. The composition of reality. Anyway, where were we? Let's see, what did you just say about... This is formula for radioactive decay. I'm gonna have to actually work some stuff out for isotope 26. Let's see. So this will be 26, why not? Or maybe not actually. It has 2 protons, right? So yeah, it must be this one. Right, where's that formula again? So variable 1 is the half-life. Man, I wish I had more monitors in this in this game. Let's see. So we got variable 0 and 1, 2, 3, 4, 5. So this is the half-life. Okay. No, 1 is half-life, 0 is time. Oops. This is time. This is half-life. Okay, so variable 2 is the starting amount. Start amount, which looks like is A in the formula. Oh no, A is the final amount, fuck's sake. And then variable 4 is the final amount. It's so hard to write on this whiteboard thing. Okay. So now we have isotope 2,6 and then variable 1 for some reason. Okay, isotope 2,6 half-life is variable 5 now. Okay. So isotope 2,6 half-life. (806,641). 806,641. Okay. Okay, I'm gonna have to write this on a physical notepad. I think this is getting too much. As much as I'd like to use the game tools. So whenever we see variable 1, it's just saying half-life, basically. is half-life variable 6 is that the first one we defined? No, variable 5 is the half-life of helium-6, which is 0.806641 seconds. And variable 6 is isotope 1125. Which has a half-life of 59.160000. Okay. Okay. So now it just wants us to divide variable 6 by variable 5. So variable 6 is 59.160000 divided by 0.806641 to 3 significant figures is 73.3. Excellent. Okay. This equals time. Space? Oh no, what's wrong? It is a sad day. Batista, you too, what's wrong? Signals 67 and 68, we skipped them. Intriguing, but why sad? Unhappy dictionary, unhappy life. Okay, if I just immediately call this space, do you guys react? No, okay. Unc equals time count 1. I guess it could be like origin or start or Big Bang. I don't know. Origin? Just want to see if the guys react. Start. Okay. Big Bang. Nothing. Alright, well. Time count 1. Now I'll just call it origin then. Isotope 26, what am I? Is this getting fused? Okay. Origin. Okay, so formula for half-life decay or whatever nuclear decay. Okay, so the half-life of 2.6, which you already got, equals 1 origin. Whatever this is. Maybe it's this version of like a second or something, I don't know. Variable 2 equals 4096 start amount. Okay, if time is 0 seconds and the start amount is 496, then assume that we have it all. If time is 1 second, how do we measure half-life? What's the time unit that we use there? The average time in which half of the atoms in a sample will decay. Oh, okay. Yeah, it seems like we're defining like a unit of time based on the half-life of helium-6, right? So it'd be 1024, wouldn't it? So I could call this year? Or second? Or, I don't know, are the guys gonna react? Okay, they react to second. The second. Well, how do you know it's the same as our second? I'm not sure. Seems to be based off isotope 2.6. I'll dig through the reference tab. Maybe something will pop up. Maybe something like time units would be more, I don't know. But whatever, for our translation it means second. Okay, so they're telling me the half-life of this 73.261 seconds. Variable 2 is the start amount, okay. The time is 0 second, and variable 2 is... I wish they'd let us name these things. Variable 2 is the start amount, so we're starting with this much. And we can assume that the count is this much. If time is 146.522 seconds, and the start amount was this much, how do I work that out? Or is it just 2 of these? So it's a quarter of this, right? $65536. Nice. What am I? Fuse time equals second. I'm not even sure if this is fuse. I mean... Do you want me to say isotope 26? Yeah, okay. Hey, Milam. It's not bad. We're up to... We're up to defining time on the basis of the decay rate of helium-6. So, pretty interesting. quiz time equals quiz term count multiplied by time? That makes sense. Hey look, it's Quiz. Another old friend. I did not expect such linguistic sentimentality from you guys. What's Quiz doing here anyway? Quiz 0, 0. Time equals 1 second. Quiz 1, 256. Time equals 1 second. Okay, I see. Wait, no, I don't see. What? How? Doesn't this contain exactly the same number of terms as... Oh no, because I see. So this is a single number. So this is actually 3 numbers in sequence. Okay. So this is 4 second. Hey, Eschaton. Okay, new concept. This concept is equal to distance divided by time. That's speed, right? Distance divided by time. Is that speed? Or velocity or something? Let's see. So time equals distance divided by velocity? Let's give that a name first, then. Okay, the guys didn't react, so maybe it's not. Oh, never mind. Feel the need for speed. Okay. Speed equals distance divided by time. Let's stop line breaking on that. Yeah, this is correct. Why? Why do you look weird? Oh, it's just because it's a natural. Yeah, okay. Word wrap. Okay, speed equals distance divided by time. Time equals distance divided by speed. So distance equals speed times time? Okay. Speed equals distance divided by time. Time is 0 seconds. We are at 0.0. Okay, we go 8 in 4 seconds. You move 1 distance a second? No? Time is 0 seconds. Oh, you moved 8 in 4. Okay, so your speed is 2 distance a second. Alright, good shit. Translation team, thanks for joining. Let's dive in. Get us started, Collins. Doppler, we're pretty excited. Oh? Do you remember the duration of each frequency? 0.8 something something seconds. 0.8066 seconds. We found the basis of said unit of time. Now once again, chemistry, or physics rather, is beyond my expertise. Dr. Akers, could you summarize how it works for us? Happily. It's the half-life of a specific isotope of helium, He6. It's their unit of time, their second. It's the basis for the transmissions, their frequencies. Goodness, it's been a long time since we've discussed the alien hertz, right? That was Batista's clever way of tracking the difference in frequencies between each signal. And now you've gotten to the root of it. The half-life of helium. Helium-6, helium with 4 neutrons. Wait, 4 neutrons? That's way too heavy to be natural. They artificially shoved neutrons into a helium atom. Which is why half of it decays in 0.8066 seconds. It's horribly unstable. Why did they choose that as the basis for a unit of time? Unstable isotopes like that can't be found naturally, since they decay before we'd even observe them. They would have to have developed quite advanced nuclear science before settling on that as a time unit. Which reinforces their perceived incredible technology. As you've demonstrated from their materials science, they're quite advanced. But why base their time on a man-made or alien-made isotope? It's artificial. How could it predate the simple concept of measuring and dividing time by units? We do the same thing on Earth. Just a decade ago, we redefined the second based off some complex nuclear thing with cesium. For what cause? So scientists all over the world could replicate the exact unit of time. Human scientists needed to normalize the second to extreme precision. We found a behavior of atoms that is exactly the same. invariant of time or place. Their unit is probably the same, a unit of time from far before their advanced science, but a unit that must be normalized for alien scientists all over the globe. And the method they've chosen is a method we can replicate even here on Earth. As creatures of the same universe, we can determine the exact duration of 1 second. 0.8066 seconds! Nice. Words named: proton, neutron, electron, isotope, fuse time, second, speed. Groups completed: subatomic, radioactive decay, time. Good shit. Status: sometimes all you can do is your role. I'm finding my place. Dude, Alan is just such a buzzkill now. Batista's log: I must work on an important update. Alan will appreciate it. Harry's diary: dear diary, why did the aliens design their message this way? I ask this not to doubt their judgment, but for better understanding. Employee of the Week celebration has served us well. I started it to boost morale and reward the translation team with something a bit more simple and, down to earth. Just a low-stakes way to celebrate particularly helpful impact. It's about time this tradition has come to a close. Plus, I'm out of my kids' trophies to lend. News thoughts. Half-Life 3 confirmed. Okay, unfortunately, I should probably quit there for the night because I have to work tomorrow, so I should probably sleep instead of playing this game for 8 hours straight. But yeah, I'll pick it back up. If not tomorrow night, it'll be the night after. So if anyone's still here, cheers for hanging out. And we'll do some more alien translation game whenever I see you next. But thanks for hanging out, and I'll see you around.